Hello and welcome back to section 7.1. In this video we're going to use example 2 to demonstrate how to solve for the internal forces in a structural member. So the normal force, the shear force, and the moment. So example 2 is here. We've been asked to cut through point C here, expose the internal forces, and solve for them. So something you should know is these internal forces will change depending on where you cut this at. The tension and compression should remain the same unless you get a horizontal force, but the shear force and the moment will change. Alright, so let's jump over to the visualizer. Alright, so I'll go ahead and draw it here, and then I went ahead and cut it at C and drew the left hand side. So I cut it here. And then I drew the left-hand side. I did not draw the right-hand side. I'm not going to need to use that. So if you kind of foreshadow the right-hand side, you're going to have by and bx plus these three things. So you're going to have 5 unknowns on that right-hand side. Whereas on the left-hand side, we only have ay plus the 3 internals. So you have fewer unknowns. So that's why I'm going to use the left-hand side when solving. So currently I have 1, 2, 3, 4 unknowns. I'm only going to have 3 equations for this rigid body diagram, forces x, forces y, and then a moment equation, or I could do 2 moment equations and 1 force equation. So that means I need to find one of these using this other diagram. So these 3 don't show up, so the only choice to find is ay. So we want to find ay with our diagram up here, and then find these 3 with this diagram down here. To find ay, without finding by and bx, we can do some moments about b. So let's start there. I'll do it up here so that it's kind of, we know what diagram we're using here. So we're going to do sum of moments about B. I'm going to assume counterclockwise positive equal to 0. So we're going about B here. So this is just a moment. No forces need to be included. So this is just going to be a straight 30 kilonewtons. So 30K, just right out of the gate. We don't need to include the distance. We're going to have AY. AY will act 1.5, 3. It'll act 3 meters away. If about B, it's going to go this way, which is going to be opposite our direction, so we need to make sure we include the correct sense. The cut's not a force. BX, BY act there, and so we have a 10K as well. So we're going to have that 10K. It's going to act 1.5 meters away, and it is going to cause a rotation this way, which is, again, also opposite. Equal to 0, and then we're going to solve for ay. So let me calculate that, and I'll be right back. Alright, that comes out to be 5 kilonewtons. So let's just separate this so that we know that this went with this diagram. You could also label diagrams like diagram 1, diagram 2, and remark that you're doing this with diagram 1. So that's all we need diagram 1 for, just to find ay. So now we know ay down here. And so we only have 3 unknowns. We can write 3 equations and solve. So let's kind of be strategic about this and see what should I do next. So I actually think we can do any of them and we'll be fine. I don't think there's anything that's going to... So we'll just do forces x to begin with. So forces x, we're only going to have this NC, and hopefully you see where that's going to go. Sum of forces in the x, I'll assume that's to the right, all equal to 0. The only force we have is this normal at C. So this is assumed to be in tension, because it is drawn outward. So NC will be equal to 0. That'll be our first answer. So you might also sometimes call this tension C. It's interchangeable. Basically, it's a normal force. All right, I'm going to scoot this up. So now we can do, let's just do forces in Y. Equal to 0. So I'm going to have AY going up, VC, shear force going down. So AY minus VC. This is a couple moment, this is a couple moments, so they won't come into the play, and this is in the x direction, all equal to 0. I know that AY, we already found that, is 5K. So that means that the shear force at this location is also 5 kilonewtons. And the last thing we need to do is find our moments, so we get to use a moment equation. So I can do moments wherever I want on here. I could do it at A or at C. Generally, the book's going to tell you to do it at C, because that way you eliminate VC and NC. Just kind of it makes it nicer. If you do it at, say, if you did it at A, then you're going to have VC and MC. But we already know everything, so it doesn't matter. But if you were trying to start off, say you didn't know what VC was, then you want to do it at C. So we'll just go ahead and just practice doing that. So moments at C. So do not get this confused. This is some moments at point C. This is the moment at C. So they're not the same thing. And I don't really know how to show that. So yeah, not an easy way. So our moments about C, we have this 300, sorry, not 300, 30K. It goes this way, which is also counterclockwise, the same as this, so we'll leave that. AY acts away from C, so we're going to get plus AY. It acts 1.5 meters away, and it'll go this way around it, so we got to put in a negative sign. And then we're going to have the, so this acts at C and this acts at C, and then this is the couple moment about C. So plus MC. Again, this and this are not the same thing, and if you wanted to write like this lowercase or something just so you don't get confused, go for it. And that's all going to be equal to 0. Again, I know AY is 5K. So we're going to get that MC is equal to a negative 22.5 after we do this. Because this is going to become negative 7.5, and we'll subtract that. So negative 22.5 kilonewton meters. And that's assuming this rotation, so positive rotation. And it's also equal to 22.5 kilonewton meters if we would have drawn it that way. So negative, so a negative couple moment. All right. Hopefully that helps. If you have any questions, feel free to contact me.